The activity of a radioactive substance is measured in curies. So curies are a measure of the number of disintegrations that happen per second. Now this number can be really overwhelming. It can seem like a really large number, but we have to remember that atoms and their nuclei are extremely small, and so if there's any sample of matter that you can see, then there are just trillions and trillions and trillions of these, and so we don't need to be alarmed by the huge number. But a curie is the same thing as 3.7 times 10 to the 10 disintegrations per second. So that's 10 billion disintegrations per second is equal to 1 curie. As we're learning about radioactivity, I know that sometimes that can start to be really scary when you learn all the places where there's radioactive substances. So we're going to calculate just how many disintegrations per second you would be exposed to from a normal household thing. A smoke detector has an activity of 0.9 microcuries of americium. How many nuclei does that mean are disintegrating per second? This is a simple unit conversion, but we're just bringing in some new units like curies. Just for an interest point, let's start by looking at what reaction we're talking about. So the americium in smoke detectors is americium 241. That's something that if you needed to actually write out the reaction would be given to you, but I just want to show you what's happening here. So if we have americium 241, if you look on your periodic table, americium has 95 protons. It has an atomic number of 95. If you follow the rules that we talked about earlier, 95 is greater than 83, so we would expect this to decay via alpha decay. So we're going to see an alpha particle come off of here. So it has a mass of 4, and 2 of those are protons. And then the rest of what we need to do is just balance this equation. So 241 minus 4 is 237. 95 minus 2 is 93. Then you look at your periodic table and you would see that that's neptunium. Now this also lets off a gamma ray. But that's not something that you would be able to know at this point in your nuclear chemistry career. Okay, so this is what's happening, and it's these alpha particles that your smoke detector detects. If it can't detect these alpha particles, that's because there's something in between the americium and the detector, and the smoke detector alarm will sound. Then what's in between them is smoke. Let's actually answer the question now and see how many nuclei of americium are decaying every second in a smoke detector. So we were given that we have 0.9 microcuries of americium, and we want to know how many nuclei that is every second. So we can go from microcuries to curies, and then we can go from curies to nuclei per second. Curies are defined as disintegrations per second, right? But what's disintegrating? The nuclei. So you could write it as disintegrations per second, or you could write it as nuclei per second. So if we have 0.9 microcuries, we can first convert that into curies. We want to cancel the microcurie, so we'll put that unit on the bottom. We want to convert to curies, so we'll put that unit on the top. And then we want to go from curies to nuclei, or disintegrations per second. The conversion between micro to curie is not changed. It's always a million micro whatever to 1 of the base unit. And then the conversion between curies and nuclei per second you can find on your reference sheet. It's 3.7 times 10 to the 10. Calculate that out. You will see that there are 33,300 nuclei that disintegrate every second in your smoke detector. That sounds like a lot, right? But remember, atoms are really, really, really small, and there are trillions upon trillions of atoms in your smoke detector, and so that's actually a very small proportion. If you're concerned about getting radiation from your smoke detector, the background radiation, just by existing and being alive, is about 0.1 REM per year. You can convert this into REM, but we won't do that right here. But if you did convert that into REM per year, then you would see that one smoke detector would account for about 0.0000025% of the background radiation that you experience every year just by being alive. The impact of those nuclei disintegrating every second is extremely small on your health, and it would be a much greater risk to not have a smoke detector, because a fire would be a bigger risk than the radiation from your smoke detector.